we are going to practice graphing the following just using what we've learned in our previous section. So first, we're going to start off with taking your first derivative. Find f prime of x. So if f of x is x to the fourth minus 4/3 x cubed, then your first derivative is 4x cubed minus 4x squared. Next, we're going to set your first derivative equal to 0. So we have 0 is equal to 4x cubed minus 4x squared. They both have a 4 and an x squared in common, so we take out an x minus 1. So your x is equal to 0 and x is equal to a positive 1. So these are your critical values. Now let's go ahead and find your critical points. By plugging in original equation. So if we had your original equation as x to the fourth minus 4/3 x cubed, I believe. Yep. Okay. So we get to plug in your x values into these equations, and I'm just going to scoot this down ever so slightly and then copy. Keep in mind you do have a calculator at your disposal if you need it. So let's go ahead and plug in a 0 piece or plug in a 1. So we get 0 over here. So we have the coordinate 0, 0. And then again at, one over here. We get 1 minus 4/3. So that's 4 over 4 minus 4 over, so sorry. Just looking at 4s. 3 over 3 minus 4 over 3. So we have a negative 1/3. So we have 1 and negative 1/3. So next, let's go ahead and we can either use your first or second derivative test from here. So if you're choosing to do your first derivative test, we could then take your critical values of 0 and again of 1, and then perform just your basic tests by plugging in perhaps a positive 1/2, a 2, and maybe even a negative 1. Nobody says you have to choose fractions just because you have fractions in there. And we get to put it, excuse me, right into your first derivative. So this could be there in your non-factored equation or your factored equation. So I'm going to put mine into my factored form, which was, I already forgot, 4x squared x minus 1, I believe. I have the memory of a goldfish. So we can go ahead and change those out. Copy. Paste. Paste. Okay. So let's go ahead and enter in these values. So -1, -1, -1. So we have 4 times a -2. So we get a -8. So your second derivative is negative, therefore you are decreasing. So we're going down. Let's do it again with this one over here. So we have, let's see, 1/2, 1/2, 1/2. So we have, let's see, 4/1/4, and then a -1/2 as a result. So we have a -1/2. So this one is also less than 0, so we're still falling. So we flattened, and then we're still going to continue to fall. And then we're going to flatten. And then we are going to look at 2 here. So we have 4 times 4, a +1. So we're at 16. So we are going to increase from there. So we should go down, flatten, up. And if you want, you can go ahead and start to do those on here. But let's say you didn't want to do this test and instead you wanted to do the second derivative test. So second derivative test, find second derivative. So we can take your first derivative, 4x cubed minus 4x squared. We can go ahead and take your second derivative. So we get 12x squared minus 8x. Step 5, what we're going to be doing now is we can go ahead and set your second derivative equal to 0 to determine actually, before then, that's not going to be step 5. That is if we wanted to determine your inflection point. Which we may as well do, but I'll probably throw that over to the other side. Maybe that's number 6. So from here, determine concavity of critical values. So we can take your second derivative and we can test your critical values when x is equal to, we said what, 0 and 1. Again, when x is equal to 1. So we can go ahead and plug them in. And if you wanted to, you can factor out your a 2 and an x if you want to make it a little bit easier or not, doesn't matter. I'm going to copy and paste this here. Copy, paste. So we can plug in the 0. So we'll get 0, which when it talks about concavity, right, we said at this value of when x is equal to 0, right? If you were, we talked about when f prime or double prime of x, we said when it's greater than 0, right? We said this is going to result in a minimum, a concave up. And when x is less than 0, it's going to result in a maximum or a concave down. But we haven't talked about what happens when it's equal to 0. Well, that would be a neither case because it's greater than or less than 0. So when it's equal to 0, we should have neither a max nor a min. And that would make sense because we were just talking about here with that concavity. Notice that there's no inflection point here. We're not changing not your inflection point. We're not changing your direction. We're not going to be positive or negative at this particular value. Whereas here, notice that going from a down to an up position, we should see a minimum. So we should see on your second one where the test does come out nicely. We have a 1, 1, and a 1. So we have 12 minus 2 to result in a 10. So your second derivative here is greater than 0. Therefore, we should be concave up to result in a minimum. Now, we did talk about just a moment ago how to find your inflection point, because we may as well find all important features of this graph. So for your inflection point, we're going to take your second derivative. We said we're going to set it equal to 0. That was 12x squared minus 2x. Uh-oh, I've been using 2 instead of my 8. How did that happen? It won't change anything, but I do like things to make more logical sense. That's still going to be a positive 4. Not sure why I put a 2 there. It will change this point here, though. So we have 0. We can take out a 2x if we'd like to start to factor. We're left with 6x minus 4. So we can see, oops. We take out, oh, we want to take out a 4. Just kidding. Wow. A 4, we're leaving behind a 3, and then again a 2. So x is equal to 0, and x is equal to 2/3 for your inflection point. And again, if we want to find your y counterpart, all we have to do is plug it back in. Find y coordinate of inflection point. So we already know the point here, 0, 0, because we already tested it over here, right? And we can be both an inflection point and a critical point. But now we have to test the other one, which, where am I? So when x is equal to 2/3 into your original, which we had f of x is equal to x to the 4th minus 4/3 x cubed. We're plugging in a 2/3 here. 2/3. Yep. Okay, so let's see. We have 81. We have 16 minus 4/3 times 3. That's 8 over 27. Let's see, 16 over 81 minus, let's see, 32 over 81. You get negative 16 over 81. Which is kind of a hard point to graph, but if we were to graph all of your points here, we have 0, 0 being one of them. We have 1 and a third. 1 and a third. Oh, that's awful. That's okay. I'll stick with it. We said we are going from down to down, and then we're going to, at some point, come back around. That some point is 2/3, so we'll back around. Come on. Oh, yep. I just changed it. 1 and a third is over here. We continue to go down. And then all of a sudden we change to go up. So this should be more of like a flat edge, and then this one should turn around. It's just a little bit difficult to squish it into that setting. So let's see if I can graph that one. There you go. So you'll see that we flatten out a little bit here because we're continuing to go down. We then continue to go down. We have your critical point here. and then another one here. And then at some point, your inflection, instead of, right, we go from up to then down, and then one more time to up from there. So we should have your inflection point graphed somewhere over there. All right, and there you have just a little bit of practice on this particular case.